Hello. Example number 69. Sketch the region bounded by the curves y is equals to 3 minus x squared and y is equals to 2x, and you use integration to determine the area, isn't it? So, for you to sketch the region bounded by these two curves, you must find the points where the two curves are intersecting, isn't it? The points of intersection. So the first curve, we have y is equals to 3 minus x squared. The second curve, we have y is equals to 2x. So the curves are intersecting at the point where they are equal, isn't it? So the point of intersection is where this equation is equivalent to this equation, meaning we solve these two equations, isn't it? How do we solve? The best method here is elimination, isn't it? The best method is elimination. So if you subtract the two curves, y minus y, you get 0, 3 minus that, you get 3 minus x squared minus 2x, isn't it? Are we together? See here we have 3 minus x squared, then minus 2x. This minus that, isn't it? So if we open those brackets, what do we get? 3 minus x squared minus 2x is equals to 0, isn't it? If you rearrange it, you get minus x squared minus 2x plus 3 is equals to 0. See, this is quadratic. If you don't want this to start with negative, what do we do? You divide all through by negative 1. So there you remain with x squared plus 2x. Negative into negative is positive, isn't it? Are we together? Then negative, positive into negative is minus 3 is 0. So this quadratic equation, which numbers gives you a sum of positive 2 and a product of negative 3? Can you use factorization? A sum of positive 2 and a product of negative 3. See, that is positive 3 and negative 1. See there? Positive 3 times negative 1, she gives you a product of negative 3. Positive 3 plus negative 1, she gives you a sum of positive 2. Isn't it? So it means factorization 1. So we have x squared plus 3x minus x minus 3 is equals to 0, isn't it? So do your factorization as you normally do. So this is x into x plus 3, x is a common factor there, isn't it? Then the second there, negative 1 is a common factor, so minus 1 and minus 1 into x plus 3 is equals to 0. You can see negative into positive, you go back to your negative, isn't it? Are we together? So what do we have here? X minus 1 into x plus 3 is equals to 0. So what does that imply? What does it imply? It implies either the first factor is 0 or the second factor is, it implies that x minus 1 is equals to 0 or x plus 3 is equals to 0. So from here you can see the first value of x is 1 or x is negative 3, isn't it? So you ask yourself, when x is 1, what is y? Because you want the point of intersection, isn't it? When x is 1, so you can say let this be x1, let this to be x2, isn't it? So when x is 1, what is y1? Where there is x, you put 1 in either of the equation, you get the same answer because they are equal, isn't it? At the point of intersection. Is that okay? So you can even use this second equation, it's more simpler. Y is equals to 2x. So when x is 1, what is y? Y is 2 when you put 1 where x is, isn't it? Even here, 3 minus 1 squared is still 2. Whichever equation you choose, isn't it? Then you go to the second one, when x is negative 3, if this is x2, then you are getting y2. Are we together? Is that okay? So when x is negative 3, what is y? 2 times negative 3, you get y to be negative 6. So when you want to sketch the two curves, you simply sketch the points of intersection, isn't it? The points of, we put the points of intersection. Then we see how the curves are turning. Which one is a maximum and which one is a minimum, isn't it? Are we together? So start. The first point of intersection, when x is negative 3, you say negative 3 to be around here, and y is negative 6 to be around here. So you can see they are meeting, they are intersecting at that point, isn't it? Are we together? Then you move again. Which other point are they intersecting? When x is 1, you can say 1 for x is around there, y is 2, y for 2 is somewhere around here. So they are intersecting at these 2 points. So we want to see how are the curves turning, isn't it? The turning, which one is curving upwards and which one is curving downwards. Are we together? For you to see the turning points, you use the second derivative, isn't it? The second derivative defines the turning point. So look here. These are our curves. Start with the first curve. The first curve is y is equals to 3 minus x squared. If the second derivative is less than 0, are we together? If the second derivative of that curve is less than 0, then it is a maximum point, meaning it is turning downward, it is turning upwards. Are we together? When the second derivative is greater than 0, then it is a minimum. It is having a stationary point, which is a minimum point. But we don't need those stationary points. We only want to see whether that curve is a maximum turning upwards or the curve is a minimum turning downward. That is what we are interested in. But we are not interested in those stationary points. Are we together? Are you getting that? So if you differentiate y with respect to x, what do you get? Negative 2. Differentiating constant, you get 0. If you differentiate yes, you get negative 2x. Then the second derivative, if you differentiate it for the second time, d squared y over dx squared, you get negative. So as you can see, negative 2 is less than 0. So when negative 2 is less than 0, it means we have a stationary point here, which is a maximum. So a maximum point, you know, is turning like that, like a mountain, isn't it? So you will see here, your curve is turning upwards like that, like a mountain. Your curve is turning upwards like that. Then it is passing through the two stationary points. Have you seen the way to sketch the curve? We are not interested at that turning point. We are only want to know whether it is turning upward or it is turning downwards, and it is passing through the 2 points of intersection. Are we together there? Are we together? We are not interested in that turning point. Okay? So you come and label your curve. This is your curve y is equals to 3 minus x squared. You go to the next one. The next curve was y is equals to 2x, isn't it? Y is equals to? So if y is equals to 2x, y is equals to 2x, look at this. Do you need to sketch that? Do you need to determine the turning point? You cannot determine the turning point because this is equation of a straight line. Hello? This is equation of a straight line, and it is equation of a straight line passing through the origin, isn't it? So you come and draw the straight line passing through those 2 points, and you can see that our linear was approximately that. We were very accurate with this irrelevant sketch here. It is a straight line. Are you seeing that? And it is a straight line passing through the origin. That is why you don't have the y-intercept. Because a curve is supposed to be y is equals to mx plus c. But this is y is equal to mx, there is no c, meaning there is no y-intercept, meaning it is passing through the origin. Have you seen that? It is passing through the origin and it is intersecting with the other curve at those 2 points. So it means what we were interested in is knowing how this curve is turning. Is it a maximum or a minimum? But we are not interested in that turning point. Okay? Are we good? So we've sketched the 2 curves. Then in Roman B, you'll be told to determine this area. The area, use integration to determine the area bounded by this region. Because you are told to sketch the region bounded by the curve y is equals to 3 minus x squared and y is equals to 2x, isn't it? So you've sketched that region. And you see now we are sketching it. We look for the points of intersection. Then we check, is it a maximum or is it a minimum? Is the curve turning upwards or is the curve turning downward? But we are not interested in what point is it turning at. We are not interested in that, isn't it?
Yes.
Good. Now after you sketch this region, you'll be told to find the area, isn't it? So what is the area of that region? How do you get the area? Let me now tell you how to get the area of a region bounded by 2 curves. This is how to get the function over area bounded. It is always, this is how to do it. Ladies and gentlemen, this is how to, it is always the curve which is up minus the one which is down. That is when you will get a positive area. Are we together? If you take the curve which is down minus the one which is up, you will get a negative area. Then you say, you ignore the negative. But anytime you take the curve which is up minus the curve which is down, when you integrate that, will give you a positive area. Is that okay? So are you seeing the curve which is upward? The one on the upper region is y is equals to? Yes, so y is equals to 3 minus x squared. Then the one which is downward is? Did you label it? Is this one, y is equals to 2x. So it is the upper one, the one curving upper one minus the one curving down. Are we together? So it is minus, we have y is equals to 2x. So you can let this to be y1, let this to be y2, then you subtract. y1 minus y2, what do you get? You get another y3. Are you seeing that? y1 minus y2, you get another y3. y3 to be equals to 3 minus 3 minus x squared minus 2x. 3 minus x squared minus 2x, isn't it? Are we together? So if you want the area, you are going to integrate from a to b of f of x dx. But what is your function of x? y? y3 is the curve defining the area bounded by those two curves. Are we together? It is the curve, y3 is the curve defining the area bounded by the two curves y1 and y2. So this means you are integrating from a to b of y3 dx. So can you do the substitution there? What are your limits? You are starting from this point. What was the x value here? You got x there to be negative. You are starting from -3 and you are ending at this point. What is the x value there? Because we are doing with respect to x. Are we together? What is the x value there? Positive 1, which is 1. Then you are y3 is 3 minus x squared minus, see y3 is 3 minus x squared minus 2x. Then you are integrating with respect to x. Have you seen what I've done? You are integrating with respect to x, meaning your limits must be the limits for x. Is that okay? And area is f of x dx, and your f of x is y3. It's a curve defining the region bounded by those two curves. Are we together? Are we together? Yes. So start integrating. Start integrating. If you integrate 3 with respect to x, you get 3. If you integrate x squared, you get x cubed over 3. So you add 1 to the power, then you divide by that, isn't it? Move on, then minus. If you integrate 2x, what do you get? So you get 2x squared over 2, meaning you remain with x squared. Are we together? You remain with x, then you put your limits. Your limits from -3 to 1. Your limits are from -3 to 1. So this is x cubed over 3. Your limits are from -3, the down limit there, to 1. So can you substitute there and tell me what you get? Substitute. Substitute the limits. This one is equals to upper limit minus lower limit. So upper limit, when x is 1, where there is x, put 1. You get 3 minus a third. 1 cubed is 1 over 3, isn't it? Minus a third minus 1 squared is just 1. What do you get with the upper limit when you substitute 1? 2 minus a third. 5 over 3, isn't it? Good. So the upper limit is 5 over 3. Then give you the downer limit when you put -3 where x is. This will be, I can say +9. Positive 9, that is 18. 18 minus 9. I can see the answer is 9. What do you have? What do you have? Oh, this is -9, isn't it? Minus 9, that is -18, isn't it? That is -18 plus 9. You get -9. What have you found with the calculator? Good, it is -9. So 5 over 3 minus -9, you get 5 over 3 plus 9, isn't it? Which is 5 over 3 plus 9 is 22 over 32 over 3. So you can see the area will always be positive when you take upper curve minus lower curve. Are we together?
Yeah.
The area will always be positive. So that is how to determine the area using integration. Are we together? Good.